let's see. We have a network. Starting with AAA, you need to look up the next element based on the next left-right instruction in your input. In this example, start with AAA and go right by choosing the right element of AAA. L means to choose the left element of CCC, ZZZ. By following the left-right instructions, you reach ZZZ in 2 steps. If you run out of left-right instructions, repeat the whole sequence of instructions as necessary. RL really means RL. So true. Holy crap. That's a lot of stuff going on there. Let's make a function called main, because that's how you know you're scripting. We're gonna read one line. Instructions. Okay, those are our instructions. We're gonna read the rest of the data into an associative array. So we're gonna make a map. Let's read another line and then cat. Yeah, that works. But instead of cat, we're gonna read each line. Okay, we can do some pre-processing on our data here. I think I just want to delete everything that's not interesting to me and then squeeze the spaces. So we've normalized our data. It looks great. And now we can read it as 3 different things. Key left right, key left right. We can do map key equals left right. Okay. So let's make a new variable called start. If z start equals key. Okay, where we start? We're starting at AAA. Let's just do this. Cur equals start while cur not equals zzz. Do done. We also need an index, which we're gonna increment at the end of every time. Can we get the length of the instructions and say index equals index plus 1% len? Yeah. Next instruction. So let's get the current instruction, which is instructions index 1. Okay, it's an R. That's good. What is it? L, R. This one would do. So if it's the right one, we do this. This is on map cur, removing star space, and then we need to figure out what to do for this next one. So we just do % space star. Okay, right goes CCC. All right, let's get rid of the break and see what happens. Okay, we get there. So what do? We do steps equals 0, steps plus plus, and then at the end we echo steps. Looking good. Okay. That's the right answer. There we go. Let's go. Part 2. The sandstorm is upon you, and you aren't any closer to escaping the wasteland. You had the camel follow the instructions, but you've barely left your starting position. It's going to take significantly more steps to escape. What if the map isn't for people? What if the map is for ghosts? Are ghosts even bound by the laws of space-time? There's only one way to find out. After examining the maps for a bit longer, your attention is drawn to a curious fact. The number of nodes with names ending in A is equal to the number of nodes ending in Z. If you were a ghost, you'd probably just start at every node that ends with A and follow all of the paths at the same time until they all simultaneously end up at nodes that end with Z. Oh no. So I can be in 2 places at once. Like, they each have a cycle. If you were going to solve this optimally, I think what you do is you figure out the cycle of each one, and then you do, like, greatest common denominator, right? I think that's how you do this optimally. I don't think we need to do it optimally. I'm hoping, because I don't know how to implement GCD in, well, we have factor. Does this help us do GCD? How do you do GCD? What's the, yeah, we could do Euclidean algorithm, but it's not exactly GCD, right? It's the other one, because it wouldn't be a number that's smaller than either of them. It's like the, or is it the lowest common multiple? I think it's lowest common multiple. Using prime factorization. Okay, if there's a way to do this, then I want to do it this way. Because we have the factor program, we might as well use it. So instead of our start being AAA, we're going to have an array of starts. If key looks like star A, echo the key starts plus equals key. There we go. Okay, so these are our starts. let's get that new example. For start in starts, do done echo start. Yeah, that's how you do that. So we just indent all of this. Can we say not z? Oh, dot star z. Okay, we conclude. We get our two numbers. Declare a cycles plus equals steps. For cycle in cycles, echo cycle, factor cycle. So all we have to do is get rid of the spaces, replace them with new lines, count how many factors there are, sort them. So that gives us them in ascending order. But we want the other way because we want the biggest one, which is going to give us we need to squeeze the spaces, and this is going to give us two things. It's going to give us our exponent and our base, and we're going to echo base to the exponent into BC. Okay. Then we just multiply those together, right? Is that our answer? Did we do it? Let's try it. No. Is this like just lying to me? Is this not correct? LCM using prime factorization. Let's find a better example. Wait. There's another step here. Perform the prime factorization of each number, then write it in exponential form. Align the common prime factor base whenever possible. For the numbers with a common prime factor base, select the prime number that has the highest power. If a distinct prime factor has no matching prime factor base in the list, immediately include this factor. Is it literally just like, I feel like we're supposed to make one big list of all the prime factors and multiply those together. Okay, I'm thinking it's this. Because I feel like this is trivial. I don't understand what exactly they want me to do. Numbers with a common base. Numbers without a common base. You want the highest exponent of each prime. Oh, wait. So the highest exponent of each prime. Okay, wait, yeah. Check this out. We can do that easy. That's the first thing that somebody said that made sense. So K1, N, K2, no. We start with key 2. So this will tell us the highest exponent of each one. And then all we have to do is go into unique F2 or F1, I think. Should trim off the we got it now. We got it now. We do a little bit of sed. We need to capture the digits 0 to 9 star space, capture again 0 to 9 star. We're gonna do 2 to the 1. Did I mean to say 1 to the 2? Okay, let's make sure we're capturing a full line here. There we go. But we want this to be the other way around. There we go. This is gonna do it. We got the number. That's the right answer.